Oh, la la la. 1, 2, 3, 1, 2, 3. And we leave. Hello. So we are making a new Discord driver. And there is already a bunch of Discord drivers. And we are also making a video about it. And I had a number of botched attempts. So it was rough with OBS. Just now the stream stopped, and so I tried to build just some Rust code, and the stream stopped apparently when OBS doesn't get enough CPU, or maybe something else doesn't get enough CPU. And by the way, this is i5, and I've noticed that when i5 is busy, then I don't know, maybe something with scheduling on Windows 10 and i5, because i7 and on another on Windows 7 i7, so the i7 CPU, right? It's rather smooth, so you can build stuff and other things works. But here on i5, if I build something, other things tend to hang for a few seconds. And what I've seen now is that OBS dropped the stream once again, simply because I've been building something. So maybe I should ask the Rust compiler to use less threads. I don't know. What I wanted to show, I forgot. So, there is this idea of attaching video messages to commits, which I think is a great idea. So this is what I wanted to show. I wanted to show my OBS settings. Just a quick flash. And experimented with Twitch, but I figured that Twitch will remove this video, so I finally signing up to YouTube and OBS in order to stream. And why stream? Because I hope to allow for like questions, suggestions, and participation. So when I'm doing a commit, I can explain the design decisions that I've made, and I can just ramble, and I can spot something and code on improving it, like we usually do when reviewing a commit. So committing something is iterative process of being. But why another driver? So we have a number of users in the bot now. So here, this code it talks to Discord, to the gateway IP. And the gateway IP tells us that it recommends us to allocate 155 shards, which is quite a lot. Especially because we cannot restart all those shards together. Because Discord also has this limit on restarts, and this is, by the way, this limit. We have 300 attempts of restarting a shard, and those are churning because some shards are not connecting right now. So we're trying to reconnect and churning through this number, and eventually this number will go to 0, and Discord will tell me that something is wrong with our bot and that they generated a new bot token for me. But this is already something that we didn't have in the old driver. Because it was hidden somewhere in the old driver, and I didn't even know about it. I didn't know that we have this number. I was trying to guess it, and I didn't know where to get this recommended number, right? So this is where we can go philosophical. In my design document, I have a section on manual versus automatic, and something I've added just today. So Jonathan Blow did a video, and I watched it recently, preventing the collapse of civilization, where he talks how software quality drops, and there is a systematic there is a system to this drop. It's not accidental, right? So I coined the metaphor of a coral reef. So while trying to think, a friend of mine asked me whether a Python is a good language, and I've noticed that Python isn't used for the structure. So we have this structure that is made of metal languages like C or C++ and Rust and other such languages. And this structure, it kind of holds everything. And Python is a very alive language. It attracts a lot of developers and a lot of change happening, but it also only exists on the margin of this underlying structure, and there is a tendency here, so it might be like a coral reef. Things are getting more stable, more unchanging, more dead, but it's a skeleton on which new layers grow, but it's a skeleton. It becomes a complexity, which maybe Jonathan Blow means when he says that if something would happen with this with all those dead layers of stable but largely um, the code is the code is stable, but the, it would also be hard to reproduce it in a moment. So if something happens with it, it will be some time before we can recreate some such structures, and especially because so ideally you would think of software design as something that is made of blocks, like have those blocks that fit together like a Lego constructor. But it means that the blocks should have a certain shape, and what we see instead is this coral reef, which grows organically without shape, and it's largely a social and psychological issue because we don't work in blocks, we don't work in ideal blocks, and we shouldn't. We would lose a lot if we would start working in blocks, but this is also a problem, that this mass of coral layers of coral reef are much harder to reproduce. They take time to grow. Um, so another thing that might be related to this is confidence. So Kent Beck, back in the old days when he was inventing and popularizing test-driven development, he wrote like, when do you test? You test when you fear. You test in order to improve confidence. Uh, and this book, it uh, kind of transfers bit by bit this idea that confidence is an important resource for a developer. So we fear is a natural adaptation that tell us not to go somewhere. So there are places where we are attracted, and there are places where we don't want to stay away from. And some practices, they lead to fear. And confidence is important because it is a measure of capability. So when Jonathan Blow tells about the loss of capability, uh, so developers, when they use all those layers of the coral reef, they are losing capability sometimes to operate on the structure. And how do we measure this capability in ourselves, we can measure it through emotion, through confidence. Confidence is our feeling about capability, right? Uh, and here I write that uh, uh, that basically when uh, basically we are just a small uh, a small living layer, like in science, they say that we are standing on the shoulders of giants, right? So we are but a small living layer uh, on a lot of complexity that goes down through operation systems and hardware and such. And when we go into these layers, we often encounter the iceberg effect that we hoped that it will be simpler, but it is uh, much harder than we thought. And Björn Stroustrup, who invented C++ language, he also popularized this idea that we should have these reusable libraries and standard C++ library that are good quality, and the developer shouldn't reinvent the wheel. And his point was, I think, that writing good library code, writing good collections, good concurrency might be hard. It might be an iceberg. Uh, so it doesn't make a lot of sense for a typical developer to go there. And this in turns lead to polarization because people who are more into this complexity, they uh, tend to shift towards this library code and they attempted to do things even more complex. They attempted to optimize, to, like Jonathan Blow says, that the aesthetic, the taste for simplicity uh, is a commodity that we need to find. That sometimes a system grows too complex. So it's like in this comic. Uh, Let me find this comic, maybe. Um, Simplicity. Simplicity, pitfall of automation, how to write good code. So library developers, there is a polarization. People who can do libraries, they it's kind of a vector. Um, uh, it's kind of a centrifugal force. I think that some people are pushed into to coding fast through this social polarization, and some people are pushed to code well. So people who develop libraries, they tend to increase this complexity, and it means that when we want to go down through those layers and fix something, we have a problem because it is now an iceberg, and we have to uh, instead of reaping the benefits of reuse, like Bjarne Stroustrup would suggest, instead we should now deal with this complexity, trying to fix something that uh, is over designed. Uh, and by the way, I love I love Linux kernel. They have a very special attitude, and I think they attract people of the same character. Uh, they like to call people out. So this code is terrible. These people, they don't understand how to program and so on. And like snob, high strong um, attitude. But it is also a sign of this polarization. So they are among a group who knows this all this complexity of the Linux kernel of the hardware, and it means they need to keep a lot of stuff in memory. Um, and they tend to look down on people who didn't invest all this time into this complexity. Um, so this is example of such polarization. So how does it relate to driver? Uh, so what I wrote here, the thought that I wrote here um, somewhere in my notes, uh, and I think it's an interesting thought that uh, automation is a form of hiding, and when we create libraries, when we create these layers of abstraction, uh, we do this in order to hide uh, all this complexity. But hiding, hiding is hiding. So this leads to me, for example, not knowing, not being aware of that the discords returns this information. So this is kind of a practical example how reusing something, reusing some reusable library Discord driver led to a lot of maintenance problems for me because I just didn't have those numbers and didn't know that I can get them. Um, But again, there is this inner conflict, psychological conflict, because if I am reusing the driver, then I am expecting to save my time. And when instead of this, I have to go and reverse engineer the source of this driver and then look into the Discord API and kind of repeat all this legwork, then something is wrong, and this is a conflict. Uh, so one of the ideas that we experimented with is this complexity of processes. So what if we do not meet the processes? What if instead we can work on the level of the operation system? Because now we have isolation in the virtual private server. So if before we had processes in order to isolate a software and prevent it from crashing some other software, this old model of isolation, it is a leaky model. It doesn't work very good. So nowadays, on new hardware, we have this novel model of isolation where we are isolated in the cloud by a virtual server. On the, so instead of isolating our process, we are now isolating the entire operation systems. So if we have this new level of isolation that is less leaky, then why keep the extra level of processes? Why not work on the level of operation systems and thus collapse this complexity a bit? And it also gives us this capability, this confidence of understanding how the operation system work and um, uh, being a bit more brave about it. So it did work well. Uh, this experiment, we do have a Linux driver that invokes Rust code and starts a thread, a Linux kernel thread. And another reason besides collapsing complexity, another reason for this is that we have a lot of messages coming to us from Discord, and this might be about applets. So uh, I would want the Discord to provide me with an ability to upload an applet, upload a piece of code that would filter the messages on their side, so that our bot would only receive messages it is interested in, right? But this is turns out to be a hard problem, and maybe WebAssembly will help with it in the long run. Um, but so far, Discord is sending all the messages to our bot, and uh, we are used in a huge number of servers, and people are constantly chatting and typing something. So even the notifications that someone started to type, someone stopped to type, someone is online, offline, all this stream of events is going to a bot, and it is a uh, it is a large number of events. Uh, and we have to filter them on our side. So basically, from all the stream, we only interested in events in the messages that start with /r, right? We are not interested in anything else, but so we are only interested in a very small fraction of these events, but they are all coming our way. And this is why we need those shards, because it's actually we don't need them. Discord needs them because they have problem some architectural problems in how this API is organized. To be specific, when a bot is started, it receives a packet of information about its servers, users, and so on. And this packet, if we connect in the context of all the servers and users that are using our bot, then this packet will be huge. It will be hard for Discord to produce, hard to send, and hard for us to receive and process. So instead, they are sharding and sending us such packets piece by piece. So they're splitting all the set of servers we support into shards, and we are limited to only connecting one shard at a time in a dozen of seconds. So this is a hard problem for us because we can't just restart a program. We have dozens of shards, and if we restart a program, they will all go offline, and we'll have to wait a lot of time before they all go back online because of these limitations Discord is imposing on us. So we have to do something that is always on and always processing all those messages. And previously, I did this by creating every shard in a process, in a separate process. This allows me to kill a process and to start a new process in its place. So we can restart shards separately. Can gradually roll out a new code. So all this old processes running old code, we kill one of the shards, start a new shard, and it's running new code now. It's this gradual rollout, which is kind of simpler than round robin implementation in two processes, which is possible to implement, but it would be, I think, a bit harder to reason about. So, but the bot keeps growing, and we have what? We need to spawn 150 processes now. It's not. It's starting to not look very well, and all these processes are there simply to filter out most of the messages and just look for the magic /r. So this is where also this idea comes from, to have a Linux module that would do this filtering for us with minimal overhead without spending context switches to deliver all these messages to the processes. But I'm not going this way right now. because turns out Discord only allows us to connect through TLS, through encrypted stream, and we do not have uh, right now a good support for encrypted streams that would work in a Linux kernel. Um, we have something complex like we can use OpenSSL or GNU-TLS to implement a handshake, secure handshake with WebSocket, and then pass the encryption specific information to the Linux kernel. And then a modern Linux kernel would help us with um, would allow us to work with this encrypted stream from the kernel, but it's a lot of hackery to do this with OpenTLS and stuff. And another option is to use embedded TLS, embed TLS, embed TLS, embed TLS library. Some people like 4 years ago managed to build it for the Linux kernel, under the Linux kernel, so it should be doable. But again, not a low-hanging fruit. We don't want to go there right now. So what I'm doing instead is that I'm building a user space Discord driver, right? And when we Rust LS, the Rust implementation of this stream encryption, they have uh, they're basically warm and fuzzy about implementing no STD. Nobody did this actively yet. I mean, someone did, but not published, I think. I might be mistaken. But they are supportive of the idea to have this running in a mode that is compatible with the Linux kernel. So maybe they will implement it one day. And maybe we'll have this stream encryption that we can easily apply from inside the Linux kernel. And then we can switch this driver from working in the user space, in the user mode, to the kernel mode. So we getting this idea of kernel side WebSockets on ice. But it's tenable idea. We just need to wait for no STD Rust LS, which I think will there is a good chance that will be implemented. And we also getting improved troubleshooting capabilities with this new driver. So we don't need. So another thing that I see a lot with people is that if they are building some driver, some implementation of an API, for some reason they think that they need to implement the entirety of it. I don't know why. Because why? You need a subset of API. Why don't you implement a subset of API and let some other people implement what you don't need? Um, so in this driver, we're only focusing on the subset that we need, but we can make it in a clear manner. And I've looked in the original Discord driver, and I think there is a lot of unnecessary complexity there. So we will have a clean room implementation, and it will allow us better troubleshooting capabilities. I mean, I plan to have a command line interface where we can um, just check real quick. So we have all those shards, some of which are now offline for I don't know why. And with this new driver, we will be able to, from the command line, say, okay, connect to this shard. And it will connect and it will tell us exactly what happens and where the error is. Right now, it is invisible, and I would need to modify this third-party driver to figure it out. I think it's will be better if in our driver we will have this available as a command line option right away, right? So this old driver, it's actually it's using a different WebSocket library that is based on I don't know what, and we are using a novel WebSocket library, which might be a big difference. There is a new WebSocket library in the Rust ecosystem that I've been experimenting with, and it seems to be much simpler and better than the previous one. So this might, and we will also won't have the dependency. So the old Discord driver comes with a lot of complexity, and actually one a major reason why I'm building a new driver is because the old driver with its WebSocket library, they depend on OpenSSL, and OpenSSL it is often a problem because if you build a new OpenSSL from source, then old Rust libraries will not detect it. If you keep an old library, then you can't build fresh Python, and the new Rust OpenSSL libraries might fail to detect the old libraries. It has been a mess with OpenSSL, and I've been switching everything for some time now to this Rust TLS implementation, which doesn't have those dependency problems, which we can build on any server where if there is Rust, it builds no problem. But this old Discord driver depends on OpenSSL, on Hyper, on Tokio, and instead of trying to port it, it's easier to just start from scratch and build on this new WebSocket library, and without Tokio, and we don't need Hyper for this particular workload. So we can go with a much simpler web server, and indeed, and in this in turns, there are different versions of Hyper. So when a library depends on Hyper, it means that it's loading a lot of dependencies, asynchronous libraries and stuff. And then another library depends on another version of Hyper, and then it is loading a different set of these dependencies. So suddenly we have a huge project with a huge number of dependencies, and this creates on confidence. So back to the confidence when a number of dependencies is small, is reasonable, it makes a difference. The project feels more lightweight, and you feel like if something breaks, you can manage to do something with it. But when a project occurs this huge number of dependencies, you start to feel that something is wrong, that something might break, and you wouldn't know what to do. And this intuition, I think, he might be right. Uh, Indeed, dependencies break, and the more dependencies you have, the bigger the chance that something will break, and that there will be some old bugs. And when you have different versions of the same library, you have to remember, instead of having a neat map of a simpler version, you have to remember that there are different versions, they work differently, they have these different traits, different runtimes, uh, running in different threads. So this translates to a real measurable mess. So that's basically let's look at what we actually coded so far. So a thought I had today is that it's a good measure, good like indicator, it's something to work towards, is to have more confidence by the end of the day, because it translates to the other day as a motivation, So today, for example, I have this command that connects to Discord and gets this data. So it does something practical. Uh, and like Kent Beck also mentioned that there is a gap between what you're doing and what you can test. And test-driven development, uh, the goal of it is to reduce this gap. So it's all about the confidence. We uh, have something working. A few hours back, earlier today, we didn't have this working, we didn't have this information, and now we have it. So this improves my confidence. And this code is inlined in main. This is exploratory development. So instead of structuring the code beforehand, I simply do it like a script, which again it makes me more confident about this particular code because I can see it on a single screen. It is really important to uh, have this transparency. Uh, and now that I've been confident that I've got this locus of confidence about this code, I can start refactor it and place it on the shelves, so to speak. Move it into library space where it will live in the future. So how should we name this? Gateway. So thanks for listening, and see you in the next commit.